Hello everyone. In continuation with the Thinking Machine series, I would like to introduce another point of view for building thinking machines. You should look at my earlier video series to get better context and continuity, which will help you get into learning groove. Building a thinking machine is one of the ultimate goals of computer science. The biomimetic approach argues that the most efficient path to this goal is not through sheer computational power alone, but by emulating the architectures and learning strategies forged by billions of years of evolution. This is not about creating AI that simply mimics human conversation. It's about engineering systems that possess the underlying attributes of biological intelligence, adaptability, resilience, curiosity, and embodiment. At its heart, biomimicry is about looking to nature not just for inspiration in aesthetics, but for functional solutions. Evolution has been the ultimate research and development engine, refining strategies for efficiency, resilience, and adaptation over eons. By studying these time-tested patterns in biology, from the intricate workings of our own brains to the collective intelligence of social insects, we can uncover novel approaches to building artificial intelligence that goes beyond the limitations of current computational methods. We aim to move from simply processing vast amounts of data to creating AI that truly learns and adapts like living systems. One of the most profound examples of learning in nature is the development of intelligence in a child. Through active exploration of their environment, physical interaction with objects, and even by making mistakes, children build a robust understanding of the world. Developmental robotics seeks to replicate this process in machines. The key here is moving beyond explicitly programmed knowledge to creating AI systems with intrinsic motivation, a drive to learn and explore simply for the sake of understanding. This involves focusing on how the robot's sensory experiences drive its motor actions, gradually building a foundational understanding of cause and effect, much like a baby learning to grasp a rattle or take its first steps. Developmental AI is guided by several key principles. Firstly, curiosity-driven learning incentivizes the AI to explore novel situations and is rewarded when its predictions about the world are incorrect. This fuels continuous learning and discovery. Secondly, sensorimotor stages emphasize the crucial role of a physical body and its interaction with the environment in grounding the AI's understanding. Finally, social learning allows AI agents to accelerate their learning by observing and imitating the actions of others, whether humans or other AI, paving the way for more intuitive human-robot collaboration. Nature also demonstrates remarkable intelligence at a collective level. Swarm intelligence, inspired by the coordinated behaviors of social insects like ants and bees, shows us that complex problems can be solved effectively through the simple interactions of many individual agents without any central command. This approach is characterized by decentralization, where no single entity is in control, self-organization, where patterns emerge spontaneously, and emergence, where the collective behavior is far more sophisticated than the capabilities of any individual member. A classic example of swarm intelligence in action is the foraging behavior of an ant colony, which has inspired ant colony optimization algorithms. Individual ants deposit pheromones as they search for food. These pheromone trails act as a form of indirect communication. Ants are more likely to follow paths with higher pheromone concentrations. Since shorter, more efficient paths are traversed more quickly, their pheromone levels are reinforced faster, leading the entire colony to converge on the optimal route. This seemingly simple mechanism, guided by basic rules and the power of positive feedback, allows the colony to solve complex optimization problems, such as finding the shortest route in a complex terrain. The probability of an ant choosing a particular path is mathematically influenced by both the strength of the pheromone on that path and its inherent desirability, such as its length. Looking even deeper into the biological blueprint, neuromorphic computing takes inspiration from the very hardware of the brain. This involves designing computer chips whose architecture directly mirrors the structure and function of biological neural networks. Instead of traditional processors, these chips feature interconnected silicon neurons and synapses that can process information in a highly parallel and energy-efficient manner. They often utilize spiking neural networks, which communicate using brief pulses of information called spikes, similar to how biological neurons operate. This event-driven approach means that computation only occurs when there is activity, leading to significant power savings, a crucial factor for mobile and embedded AI applications. To unify these paradigms, I propose a hybrid biomimetic model that brings together curiosity, perception, communication, local rules, and metacognition, forming a layered, interacting system capable of learning and adapting in complex environments. Looking ahead, the future of artificial intelligence is likely to be shaped by a powerful fusion of biomimetic principles and traditional AI techniques. By learning from the elegance and efficiency of natural systems, we can pave the way for the creation of AI that is not only more intelligent but also more adaptive, resilient, and energy efficient. This holds the potential for transformative breakthroughs in diverse fields, from robotics and healthcare to environmental monitoring and beyond. Ultimately, the promise of biomimicry and AI is a future where technology and the natural world work in greater harmony, creating intelligent systems that truly serve humanity and the planet. I am now happy to take any questions and comments. I will further share the more insights and details about how to build thinking machines and underlying principles in my coming video series. Please subscribe my channel and like the video so that I can bring interesting insights and updates on thinking machines.